So we are going to learn how to find the lengths of segments today based off of what kind of segments they are and what happens to them. So, I'm sorry. I'm a little confused at what I have up here. Anyway, for a given point and a circle, the product of the lengths of any two segments from the point to the circle is consistent along. Ooh, I don't like that. Okay. You lost mine.
Was it on your neck the entire time? Yes. What else would I do?
I hope it didn't flush down the toilet.
I didn't go to a toilet.
So where did that go?
I went to
So looking at A, first of all, chords are segments in a circle that end on the circle. They don't go past the circle. Secants are lines that go through the circle, so they go outside of the circle. And then a tangent is one that only touches the circle once on the outside. So looking at A, do I have two chords, two secants, or a secant and a tangent? Those are the three options that we're looking at. Two chords, two secants, or a secant and a tangent.
Two chords.
Two chords. Okay. So two chords is what we have here. Okay. How do I know they're chords? Is because those lines don't extend past my circle. Okay. What about B? Two chords, two secants, or a secant and a tangent?
Two secants.
Two secants. And then C, two chords, two secants, or a secant and a tangent? Secant. Yeah, the secants go outside of the circle. The chords do not go outside of the circle, and the tangents only touch the outside of the circle. Okay. Right. Okay, so here's what happens. Listen. That theorem was talking about the product of certain parts, and it didn't make a whole lot of sense, right? So for two chords, this is what we do. We take the pieces of one chord. Okay, so I'm going to talk about the pieces of this, maybe, of this first chord. What are those pieces labeled? A and B. We are going to multiply those. A times B. One piece times one piece. And then we look at the other chord. What two pieces are labeled there? C and D. So A times B is going to be equal to C times D. It is piece times piece equals piece times piece. Okay, one piece times the other piece of that chord equals one piece times one piece. Okay, so that's what you do with two chords.
So if there are multiple little pieces?
No.
The four piece?
Okay, are we ready? Listen. Two secants. It is the whole secant times the outside. Okay, so if you see x plus w, that's my whole secant, times my outside. Whole times outside is equal to the other whole secant, z plus y, which is right here, times the outside, whole times outside. So two chords, piece times piece equals other piece times other piece. Two secants, whole times outside equals whole times outside.
So with the two chords thing, why does that work?
I don't know. Because of that theorem. What has been proven years and years and years and years and years and years ago before any of us were ever a thought. I don't know. I don't know the reasoning behind it. I just know it works. All right, hold on. Let me do this last one. Listen. When you have a secant and a tangent, it is my tangent squared. Okay, so t squared, my tangent squared, is equal to the whole secant times the outside piece. And then they had to prove it over and over and over again, yes. With proofs. Okay, so three things to remember. Adam, are you writing any of this down, or are you just... Did you write the words too? At the bottom.
He did not.
Someone said.
All right, first of all, we're going to multiply x times x plus 8. But I'm putting that x plus 8 in parentheses because how many parts does it have? 2. So that x is going to have to multiply by both. Now the other tangent, each piece has 2 parts, correct? So we're going to put them both in parentheses. So far, so good? Okay, now we're going to multiply. This x gets distributed by both. And for some reason, this isn't writing well. I apologize. And then we're going to have to FOIL the other side. First, outer, inner, last. Now, before I do anything, I'm going to combine my like terms. And I'm going to stop for a minute to make sure everybody understands where all of those numbers came from. This one? So x times x plus 8. Okay. So far, so good. Does anybody have any questions on what I've done up to this point? All right, now we've got to start solving our equations, which means I need to get all of my like terms together. I always start with the highest degree. And what happens when I start moving this x squared over here? What do? They cancel each other out. So that leaves me with 8x equals 6x plus 8. Now I need to subtract my 6x. So that's going to be 2x equals 8. So therefore x is going to equal 4. Does everybody understand?
You guessed it.
All right. Now look, these lines right here are just showing you the length of the whole thing. It's not easy to draw the little braces in the computer, okay? So that's the same thing as saying like that. That's all that's doing. Yes.
So wait, what does it mean?
Well, we're going to talk about it first, right? Is everybody ready to start number 4? I'm just going to do that one, then I'll let you do 5. I'm going to do 4 because we haven't done one like this yet. I mean, you can keep going. All right, first of all, in number 4, 2 chords, 2 secants, or a secant and a tangent? 2 secants. So, whole times outside, and it doesn't matter if you start with the top or the bottom. How do I find the length of this whole? You add them. 4 plus 2 is 6. So it's going to be the whole times what's the outside piece? 2 equals, be careful here. What is the whole going to be here? X plus 3. Times the outside piece, which is 3.
Wait, is that a 6 all the way?
Yes. Sorry. There. Well, there, that's better. Make sense? All right, what's 6 times 2? 12. Now, because I have this 3 that needs to multiply by x, and it's going to have to get distributed to both. Whoops. So that gives me 3 equals 3x. So what is x going to be? Now I want you to try 5. It's actually even easier than 4 because 4 we had to find the whole piece first. Okay, again, secants are whole times outside equals whole times outside. You just have to recognize, do you have chords? Do you have secants? Do you have a secant and a tangent? Because that's what we're finding. That's not a tangent. Is that right? Yes. There is no tangent in this picture. You talking about the outside piece, though? Yes. The X is the whole line. It's just I can't draw these little things in the computer with. That's what that is. That's just showing you what the whole line is. What?
How is the whole thing?
How's the whole thing entirely X but it has a 5?
Well, because I don't know what the inside is, so I got to figure out what X is. No? Okay. Top line. What's the whole top line? 10 times, what is this outside piece?
4.
Oh, it's X plus 5.
4.
Yeah. Oh my god.
And what's the whole piece on the bottom secant? No? X times what's the outside piece? 10 times 4 is 40. 5 times X is 5X. So what is X going to be? 8. So the length of my whole thing is 8. If I wanted to ask this, I could subtract to get that's 3. 8. Are we still confused as to why we're just trying to find the whole piece, that's all. Looked weird. So we've done 2 chords, we've done 2 secants, so we should probably do a secant and a tangent next in a minute, maybe? No.
I'm putting your ears.
We good? Oh, okay. I want you to try 6 and then we'll talk about 7. Okay, take a minute, try. What do? You add them. So if I add 3x plus 2x, that gives me 5x. Okay, so that's the first mistake some people are making. They're saying it's 6x. So we're going to take the whole piece 5x times what is the outside piece? Okay, and then what's the other whole secant? Times its outside piece is, okay. Here's the second mistake you guys are making. 5x times 2x is not 10x. It is 10x squared.
Why is it?
Because x times x is x squared. Multiplying the exponent changes. Adding the exponent stays the same. Okay? And 10 times 4 is 40. Now, shh. Somebody else asked, what do we do from here? You need to get x squared all by itself. How do I get the x squared by itself? Okay. So x squared equals 4. And how do I undo a square? Square root. And what is the square root of 4? Everybody okay? Are you sure? Okay. Thank you. All right, let's look at 7. What do I have? A tangent and a secant. So when we set this one up, I need my tangent squared. What is my tangent labeled in my picture? Okay, so we're going to go x squared equals, what is the whole secant down here? Times, what is the outside piece? So x squared is going to equal 44. Okay. 44 is not a perfect square, but we can split it into 4 times 11. Okay, tangent squared equals whole secant times outside piece. PJ, shush. No commentary from you either. Shush, both of you. I don't know. No, I don't think so. All right, try those 2. So if I'm talking about the whole secant, what do we do to those 2 parts to get the whole?
You add.
I add them. How do I do 2 plus x? What does it look like?
2 plus X.
Yes, it looks like 2 plus x. Okay, so when you have the whole piece, it's 2 plus x, but then you need to multiply that by the outside piece. What's the outside piece? 2, and then that's equal to your tangent, which is 6. And what do we do to that tangent? Square it. Okay, shh. I need everybody to stop talking. I'm going to I'm going to multiply this 2 times both of those, which is going to give me 4 plus 2x, yes?
Yes.
And 6 squared is 36. Then I'm going to subtract my 4 over. So 2x is going to equal 32. And so x is going to equal 16. Okay. Again, for number 9, what is the whole thing? All right, so we're going to go 6x times what's the outside piece? Equals my tangent squared, correct? 6x times 2x is 12x squared. 6 squared is, okay, got to get the x squared by itself first. What's 36 divided by 12? 3. And then we take the square root. Is 3 a perfect square? Does it have a perfect square in it? So we leave it as